Hi, and welcome back to Math with Sophia, a part of Sola Math. Find more math resources at solamath.com. In this video, we'll be covering how to identify the end behavior of the graphs of polynomial functions. To do that, there are two things we need to pay attention to in our polynomial functions, and those are the degree of the function and the leading coefficient. The degree, we need to know if it's even or odd. And the leading coefficient of the function, or LC, we need to identify as either positive or negative. So before we get into the end behavior, let's make sure we can identify the degree and leading coefficient of some functions. So here we have two examples. Looking at this one, let's identify the degree. So the degree is the highest power of the function. Here we have an x to the third and an x squared, so this is the highest power. So if the highest power is 3, the degree is 3, is that even or odd? That is odd. Now let's look at the leading coefficient of this function. So the leading coefficient is the coefficient that's with the variable that has the highest power. So the x to the third is the highest power, and the coefficient of that is a -1. So our leading coefficient is negative. Let's look at this example here. The degree is the highest power, so we have a 4 and a 3, and so this is our highest power. Since it's 4, our degree is even. It's an even number. And our leading coefficient is the coefficient that's in front of the variable with the highest power. So in this case, it's a 3, which is positive. So these are the things that we will need to identify about our polynomial functions in order to be able to determine their end behavior on their graphs. And to understand their end behavior, there is a useful chart that we will look at. This is the chart that will help us understand end behavior. This column right here is for polynomials that have an even degree. This column is for polynomials that have an odd degree. This row is for polynomials that have a positive leading coefficient, and this row is for polynomials that have a negative leading coefficient. So this graph will represent a polynomial that has an even degree and a positive leading coefficient. That would be something like y equals x squared, or y equals x to the 6th, and so on. So a polynomial with an even degree and positive leading coefficient will always go up on the left side and up on the right side. And the middle can have any kind of shape. And that makes sense because if we think about y equals x squared, that's a quadratic equation. And quadratic equations with positive leading coefficients are that U shape. And as you can see, it goes up on the left and up on the right. So our end behavior for even degree polynomials with positive leading coefficients go up on the left and up on the right. Now let's look at a polynomial that fits these characteristics. So an even degree polynomial with a negative leading coefficient. So examples of that would be y equals negative 4x squared, y equals negative x to the 4th, and so on. So if we think about transformations and what a negative sign does to a function, it flips it over vertically. So instead of pointing up like this, like we said with our quadratic, for example, or even with this polynomial, it's just going to be pointing down. So our end behavior of even degree polynomials with negative leading coefficients is going to be down on the left and down on the right. And the middle can have any kind of shape. Now let's look at odd degree polynomials with a positive leading coefficient. So an example of this would be y equals 2x to the third, or y equals x to the ninth. In this circumstance, the polynomial points down on the left and up on the right, and the middle can have any kind of this squiggly shape. So the end behavior is down on the left and up on the right. Now let's look at odd degree polynomial with negative leading coefficient. So an example of this would be y equals negative 4x to the fifth, or y equals negative x to the seventh. So just like we talked about the even polynomials, the negative flips our original function vertically. So instead of going down on the left and up on the right, we're going to flip it like this, and it'll be up on the left and down on the right. And then the middle can have a whole bunch of squiggles. Up and down. So now using this table, we can determine the end behavior of any polynomial function. So let's look at some examples. Here we have y equals negative x to the fourth plus 2x to the third. So we need to identify the degree and leading coefficient. So the degree is 4, it's highest power, so the degree is even. And the leading coefficient is negative. So it's going to be down on the left and down on the right. And remember, we only know the end behavior based off of these things. We don't know what happens in the middle. So we have to draw some sort of dotted line to indicate that we don't know exactly what happens in the middle. Now let's look at this function over here. So y equals x to the eighth plus x to the fifth minus x squared. Our degree and our leading coefficient. Our degree is the highest power, which is an 8, and that is even. Our leading coefficient is a 1, so that is positive. So even degree with a positive leading coefficient, that means it's going to be up on the left and up on the right. We'll draw our squiggle in the middle. All right, let's look at some more examples. Here we have y equals x to the third plus 2x squared minus 7. So our degree, the highest power is 3, which is odd. And our leading coefficient is 1, which is positive. So odd degree with a positive leading coefficient is down on the left and up on the right. And then we can do our middle squiggle. Now let's look at this example. Y equals negative x to the fifth plus 12x squared. So our degree is our highest power, which is the 5. So a degree of 5 is odd. And then our leading coefficient is negative. Odd and negative. Odd means they're pointing in opposite directions, and negative means it's going to be up on the left and down on the right. So that is how you identify the end behavior of polynomial functions. A good way to remember this is to look back at our chart and notice the patterns. So for example, even degree polynomials, their end behavior on the left and right is always going to match. So if it's pointing up on the left, it'll be up on the right. If it's down on the left, it's down on the right. And then odd degree, it's opposite. If it's down on the left, it'll be up on the right, and vice versa. And then the only other thing we have to keep in mind is the leading coefficient. So one strategy to help you remember this chart is to use examples in each category, some examples of parent functions. So even degree with a positive leading coefficient, a good simple example for that would be y equals x squared. That we know is a parabola, a U shape pointing up. So we know if that points up on both sides, then all the other polynomials with these characteristics will also point up and up. And for odd degree with positive leading coefficients, a good example would be y equals x cubed. That has the shape pretty much what we have drawn right here. And so if you remember y equals x cubed looks like this, then you'll know that all polynomial functions with these characteristics will go down on the left and up on the right. Then for the negative leading coefficients, remember that it's flipped vertically. So if positive is up and up, then negative will be down and down. If the positive is down and up, then the negative will be up and down. And that is a summary of the end behavior of polynomial functions. If you enjoyed this video, hit the like button and subscribe for more.